Howdy, it's Tubalcain again, and in my last several videos I showed how to install this VFD on a drill press, and that was done in several videos, so be sure and go back and watch those if you have not, and tell your friends about this, because this is pretty much information that I had to learn all by myself. And this little mystery box here is really an amazing thing, and it's called a Variable Frequency Drive, or a VFD. This particular one cost $119, but they soaked me over $20 for postage for that little thing. I was rather peeved on that because I know what postage should cost. That could have been done for $11 a priority. So I was ripped off on that, but I do like the unit. Came out of New Jersey, and it's a Teco or a Tico Westinghouse, which has no more to do with George Westinghouse and the Man on the Moon anymore, but that's what they call it. Now here's the model number on that, should anyone be interested, and you can look that up on Google and quickly find it and even find out where I purchased it, and I do not promote that company. Yeah, they were fine. It was real good shipping, other than it cost too much. I mean, it was real fast and easy. But what I like about this particular model is that it converts 110 volt, because a lot of them are 220 volt. This converts 110 volt to 220 three-phase. There's a three-phase motor on this machine that I just recently replaced. And so because of that, I am able to change the speed of the motor and even reverse it. Not that I think that I will ever need that on the drill press, but the purpose of this video is to show you how to program this little beauty. The installation of it, again, was on previous videos, so go back and watch those. This device did come with a rather thick book, but do not be confused by the thickness, because it's half in Chinese. You know, why do they do that? They know they're sending these to America, probably most of them. You know, I almost like to tear that out and throw it away, because I don't read that language. Other companies do that too, you know. If you want to send your VCR to France, give them a French booklet. Give us the English booklet. Don't double up on it. But that seems to be an international thing that's going on. Excuse the rant. But the problem with this thing, look at how big it is, you know, not even as big as my hand. You printers out there know what two-point type is. Well, this thing is printed in two-point type, and it's impossible for me to read at my age without this thing. However, they did also include a CD, but I'm not always in the mood for going up to the computer to read this. But a lot of this is foolishness that you will never read or never understand, the same as every manual, as well as the first 6 pages for safety. Now, I'm not belittling safety. You can't be safe enough around electricity, and so do go ahead and read that and understand it before you attempt to install one of these or work with one. Now, there are over 100 parameters in here. In other words, things that you can program into this device. However, most of them you'll never need, or I certainly do not need. There's about 8 or 10 that I'm interested in, and some of them are what they call advanced. And I suppose if you're into automation or in a factory or something, some of these would be useful, but they certainly aren't to me. So I'm going to show you about 6 or 8 of these that I found interesting and that I'm going to program into the device, and you can take that for what it's worth. As with any electronic device or computer, and in a way this is a computer, it comes with factory defaults. And should you goof up your programming, you can always go back to the factory defaults, and I'm going to show you how to do that real quickly. And this is at a default now, which is 0.5, and that's, or 5.0, and that is the way it comes out of the box, and it will be blinking. I'm going to power it down now. I did this in the other video. But when I power it back up, the first thing that it's going to do is to flash the voltage. Even though we call this a variable frequency drive or a VFD, it's also referred to as an inverter motor speed regulator, and that's on the front of the manual. And on the packing slip they actually say, and by the way, the capacity for this is 1 horsepower. They make them smaller and they make them larger, but I think if you go larger you're going to have to get 220 volt. But in the packing slip here they call it 1 horsepower, 115 volt, and it can be used as a phase converter plus get your variable speed. Single phase input only for this particular model. So you do not need a phase converter when you use one of these. This is the phase converter. Now watch the readout as I power it up. And the first thing it tells briefly is the voltage, and that's 110 volts, and then it goes to 5, and that will flash. I'm going to turn the motor on now. I'm going to hit run. The blinking stops when you do that. Now if I want to raise the speed or increase the speed of the motor on the keypad here, I'll move in just a little closer so you can see what's on the keypad, although I got a bit of a glare there, but there's arrows up and down, so when I push the up and down I increase the frequency. Down will go the other way. Now at this point the potentiometer or the dial does nothing. So I believe that's the very first thing that I'm going to program in, because that's disabled right now, like it doesn't work. Now let me tell you what these numbers mean. That means 60 cycles per second right now is what it's set at. So the motor is running at its fullest speed. Remember that in the United States the frequency of our current is 60 cycles per second. So it's at 60 cycles per second right now. Now if I move this back down to 30, it'll be 30 cycles per second, and the motor will run at half of its rated speed, which in this case would be around 800 or 900. This is about a 1700 RPM motor. So we're running now at about half speed, and you can see that the spindle is running slower now, but of course this machine is going through belts, so this isn't the motor speed, this is the final spindle speed. So that's what those numbers mean. It does not tell the RPM. I wish it did. I wish I had a tachometer on here. Remember, not all brands will have the same keypad, and certainly all different makes will not have the same function. So I'm really speaking here of this model and this brand, which is a Tico. Very simple keypad. We have up and down arrows. We have stop, run, which is really on and off, basically. And then we have the function button and the enter or the data button. So with those instructions in mind, and this is the potentiometer, and I think the very first thing I will do is to activate this. Okay, the frequency command source is 05, and if I enter 3 zeros, it would be the up and down key to change the speed or the frequency, but that's what it's set at now. That's the default. I want to change it to the potentiometer on the keypad, so the command for that is 001. So let's look down here on the keypad, and I will push function, and I want 05, so using the keypad here, the arrows, that's 05, and then I push enter, and now I want 001. And again I'm going to hit enter. It says end, and I'll hit function again. Okay, now I'm going to power up the machine. Turn it on, that is. Run. Now let's see if the potentiometer works. And it does. Now I'm able to more quickly set the speed of the machine by turning the potentiometer. So there's a 60, that's maximum, and I can very quickly go down to whatever I want, whereas using the arrows took a lot of time, so I like that. Also, a remote potentiometer can be hooked up to this using some of the various other input screws down here that I showed in the other video, so be sure and look at that in the other video. But now the potentiometer is activated. Next function that I'm going to change for demonstration purposes is the acceleration time, and the default for that is 5 seconds, and deceleration time also default of 5 seconds, and the codes are 01 and 02. But first let me explain what I mean by the acceleration and deceleration. Now I'm going to turn the machine on, and notice that the chuck doesn't come up, or the spindle doesn't instantly come up to speed. It will take 5 seconds to come up to speed, and that's called ramping up. So here I turn it on, and it took 5 seconds to come up. Similarly, when I turn it off, I'm going to show you the readout. I'm going to hit the off, or stop, actually they call it. Watch that it takes 5 seconds for it to come back down to a complete stop. Yeah, it was 5 seconds. That's the default. Now, why would you ever want to change that, or why do we have a 5-second acceleration and all that? Well, if you had a great big heavy chuck on a machine, you want to come up to speed a little bit slower, or you certainly don't want to stop it instantly because a chuck can spin off or you can damage a machine. Now, I'm not going to change both of these, but let me just change the acceleration time. And in order to do that, function, and 1, enter, and see, that's the default, and I'm going to change it to 1 second. There's 1 second, and I will enter the data, which is end, and then hit that. Now watch the chuck when I hit the start, because it should come up to speed in 1 second. In other words, it appears to start almost instantaneously. We could do the same thing with the stop or the ramping down. I'm not going to show you that, but the principle is the same. By the way, the blinking is normal, so it should always blink. Now the next one I'm going to show you, the next function, is called the motor rotation. So in other words, I can reverse the motor without reversing wires like I showed you in one of the other videos, or without using a reversing switch. This would not at all be handy if you were going to tap or something and wanted to reverse it, but just to show you that it can be done, and that is function 3, and 0, 0, 0 is forward. That's the default. It would be on that now, and I'll change it so it runs in the reverse direction. Now I will reverse the rotation on the motor. Function 3, and that's the default, forward. It's on the default, and I want to change it to 001. Enter. Now watch the spindle when I hit the start button. And it is running in reverse. But you can see that wouldn't be a quick way to do it if you wanted to go from forward to reverse, that is tapping and then backing it out. It wouldn't be suitable for that. This is a function I really find interesting, and to me it's absolutely amazing that we can run our motors at a higher speed than what they were designed for or built at, because normally the speed of a motor in America, maybe around the world, is a function of the number of poles in the motor, and the frequency. Well, 60 of course is what we got here in America. That's our standard frequency, 60 cycles per second or hertz. But with this function I can increase the speed of the motor to greater than 60 cycles, so it's going to give us a greater RPM, and that's function 7, frequency upper limit up to 200 hertz. So in other words, we can run this motor at over triple its speed. Now be cautious with that. That kind of scares me, because you could run some motors so fast I think they could fly apart. And so do not do that. But I'm going to change the frequency to 100. I'll make it 120. That'll be double the speed. So in other words, this 1700 RPM motor will run at about 3400. So to change the frequency, function 7, and it's at 60 now, and I'm going to change it to 120. Kind of a slow process. There we go, or I'll be at about 120 wherever it stops. Oh, way too fast there near the end. Alright, that's 120. Enter. So now the frequency is 120, and I'm going to start the motor. Now that motor is running at 3400 RPM. And in fact, it scares me it's running so fast. I'm going to turn it down because we got a vibration. And just as I warned you, you don't want to run these motors too fast. But the point being here that we can speed it up. Now off camera I'm going to return that back to the way it was, back to 60 as the again, upper limit. Yeah, that made old Tubalcain a little scared here when it started vibrating, so be forewarned. By the way, if I did not mention it, do all of your programming with the motor turned off. Now this function 9 is the stopping method. The default for stopping the motor is to decelerate to stop. In other words, it ramps down as we just showed you, and the default was 5 seconds. But if you don't want any of that, you can just have it coast to a stop by changing it to 001. Now for function 09, 09, 09, there it is. And remember, this is the default decelerate to stop, and I'm going to change it to coast to stop. Enter. Now I'm going to change the camera down to the chuck again, which is still running in reverse, and I'm going to turn it on. And now watch it as I turn it off, that it will just be coasting to a stop, the same as if we did not have this device on the machine. I'm turning it off. So it's just coasting. That's how fast it stops, just with friction and gravity. Thank you for watching this video, and I think some of you appreciate what this all stands for here, but I tell you, about a week ago I would have given $100 for this lesson that you're getting here on YouTube, because I just started with a manual that was almost incomprehensible. So this might be the best function of all, and that's function 52, and that will take you back to the factory defaults. So if you just get confused and you want to start from scratch, use function 52, and it will return the unit back to the way it was when those delicate Chinese fingers packed it 6 months ago. So here we go with function 52. I already had it on 52, so I don't need to change it. And it needs to be 20. That was the code, 20. There we are, set, end, and notice that it's now blinking at 5, which is what it was originally when I first fired it up. And I'm going to start it. So it's going to run very slow, which is the way it first did. So this is 5%, or 5 cycles rather. And also notice that it's now rotating in the correct direction for the motor or for drilling. So I'm back to square one, and notice that the potentiometer does not work now, so everything else that I did has been really erased. And those of you that know about computers know what I'm talking about at defaults, and some of you possibly don't understand some of the terminology. But there we are, back to square one. Now what I intend to do is take all my cue cards here, and I'm going to make up just a small master chart on the back of one of these that will have all of these functions, because I just believe those are the only ones that I'm going to use, but I'll hang on to this for reference. Plus I have the CD upstairs in my computer if I need any other functions, but I believe that's all I need here on this drill press. And the whole project here on the drill press was in order to practice. So I spent $119 plus postage for this thing so I could practice, because what my real goal here is, I intend to put one of these, a little bit heavier duty, bigger one, on my Bridgeport mill to eliminate the use of the step pulleys, so that I can quickly change speeds without the nightmare of step pulleys and back gears. So that was really my goal. But I think this is an amazing little device. Some of you might very well want to put one on some of your machines, and they'll work on virtually any machine, you know, because they make these for single phase and for 3-phase, and for all the different voltages. So I hope you found this interesting. Give me a thumbs up if you did, because I'm trying to find out what you YouTubers out there, you machinists, you home shop machinists like me, are really interested in. But to me, this is fascinating. And if you're old school like me and grew up with regular drill presses and regular motors, and now what we can do with something like this absolutely blows me away with the technology. And I hope this is a durable piece here that will hold up and is not troublesome. But with all that in mind, this is Tubalcain saying so long for now.